Hey, welcome to the Web3 Asset Graphs workshop. I'm Branimir, CTO and one of the founders of Trace Labs. We're core developers of OriginTrail. And today I will be speaking about something that's probably not that common among the Web3 space. I'll start with a bit of an intro, and then we'll actually show a little bit on how you can build these Web3 asset graphs. We'll be actually speaking about basically first intro into knowledge graphs, what is OriginTrail. We'll be speaking a little bit about digital assets in the Semantic Web3, might be a new term, so we'll try to define it. We'll do a brief tutorial, and stay tuned, there's some bounty at the end. And of course, Q&A, of course. So whatever you guys feel like is not clear enough, feel free to raise your hand and ask at any moment. I'm doing this for the first time, so it's a bit long, might be a little bit too long, might be a little too packed. So yeah, bear with me and help me out if you see that something is not totally clear. All right, so 10 minutes in, let's get going. So to first introduce OriginTrail and who we really are it's important to put up our mission statement. We are organizing humanity's most important assets, making them discoverable, verifiable, and valuable. And actually, I'll be focusing on all of these highlighted terms today. All I'm trying to put in front of you is this idea of where we're heading. And I actually want to start with a question. So what do you use today when you want to find something on the web? When you have Google, all right. Anybody DuckDuckGo? All right, here's one. Quick answer, very good one. So it's interesting because we'll be speaking today about how we can create basically a Google for Web3. How do we take this technology that's been predominant in Web2 and actually make it decentralized and on the core principles of Web3 as we celebrate here at ETHDenver. Awesome. So keep that in mind. We'll be speaking a little bit googly talks today. So OriginTrail is actually the world's first decentralized knowledge graph. And right now it's actually a multi-blockchain decentralized knowledge graph. I'll explain what that means in a moment. It is really a decentralized semantic layer that synergizes blockchains and knowledge graphs. And I'll explain how that works in a couple of slides. Right now, it's a network running on the mainnet in version 5 with over 2,000 nodes. It's a permissionless network, so people around the world, people and companies are running these nodes, really supported by the OriginTrail community and incentivized by the Trace token. It's been launched in 2019, so it's been here for a while, actually deployed in quite a few places. I'll show some of them today. And right now we're in this phase of launching the version 6, and I'll be speaking about this new version 6 today. So if you try to position it in a sort of a tech stack terms, the most simplest possible illustration is this one. So it's not a blockchain. That's the first thing that I always try to put out there. It is a decentralized knowledge graph. So it's a network that sits, let's say, on top of blockchains. And currently it connects to Ethereum, to Gnosis chain, or formerly XDAI, Polygon, and soon to be Polkadot, Akala, and actually the very own OriginTrail parachain. So it's a bit of a different network, and then on top of it, obviously, we can build some very interesting features for Web3 applications, and I'll show some of them today. But before we go really quickly into that, I know you guys know about blockchains. I'm sure what I'm going to say on this slide is very familiar, but I just want to make one point that blockchains are really trust networks. And as these trust networks, they actually run on decentralized stateful protocols, which enable a verifiable shared state, right? But the difference, for example, from HTTP, which is stateless, we get this common state, which sort of everybody shares and is able to trust because of, well, blockchains being trust networks. So we get all of these cool things like having a tamper-proof shared ledger, decentralized identity is one of the great things that comes from these properties. Tokenization of assets, I'm sure I don't need to speak about that here. Decentralized finance, all kinds of trusted multi-party computation. Blockchain is great for that. With all of the bottlenecks, we know about them, but essentially it's a trust network. Knowledge graphs, on the other hand, are semantic networks. And what that really means is that we're moving, and as Google says, we're moving from this notion of strings and going towards things. So things, not strings, is like the easiest way to explain it. And the idea is to actually go from somewhat raw data into something which is quite structured and linked, and in that way actionable. And these companies that you see on the screen, Google, Facebook, Amazon, Uber, pretty much everybody, NASA, all of them actually use knowledge graphs heavily. So the Web2 world has been, well, the biggest actually companies in the Web2 world have been building on top of this, synergizing data from their different, different systems. And the consequence of all this is that they actually built a ton of value. And the worst part of it is all of this value is locked into these silos, right? Google having their own, Facebook having their own, and so on, and quite often used for, well, not the best purposes for humanity, I would say. Either targeted ads or like attention grabbing, in the sense that they might even go into some sort of programming. But I'm not here to bash them. All I'm here to say is that this is very powerful technology, and that it's really essentially a semantic network. And this term semantic actually comes from the man himself, Tim Berners-Lee. So he actually coined this vision of semantic web quite a while ago. And actually, he called it Web3. That was back 20 years ago when he named this term. So a little bit of history. He said the World Wide Web, which he created, was about document exchange. Then Web2 was about really interacting, so kind of building this social web. And then Web3 for him was about meaning and value exchange. And he called it the semantic web, right? So it's the biggest inventor of the original web had this idea for Web3. He actually gave us an architecture for it. And this architecture, it's actually very interesting to see now, 20 plus years later, to analyze actually what he had in mind. So if you look at it a little closer, there are some things I'll be mentioning a little later here, but everything's basically built on identifiers or the URI. If you've been touching NFTs somewhat, you surely know about token URIs or uniform resource identifiers. Then there's a bunch of stuff on top, XML, RDF, we'll touch that. And there's this Sparkle query language, which is also very interesting. A bunch of this purple stuff, which is very cool. And then there's this bluish stuff on top, blue-green color, whatever that is, which kind of he added on top a little bit of proof and trust, right? He knew it was needed, but it wasn't kind of like, still wasn't there, right? Cryptography permeates the whole thing, right? But, it was kind of assumed that you have some like component of trust. Either you trust the source that you interact with or company or whatever, and there's some notion of proof. And I would argue, my personal opinion, is that the semantic web hasn't been fully realized as the vision of Tim Berners-Lee was, exactly because of these top layers, exactly because we didn't have what we have today as Web3, as this trusted shared environment or trusted networks which are based on trusted technologies, right? So, but the ideas were really good, and actually they were captured by all these knowledge graph companies. So Google heavily utilizes semantic web principles and all of these technologies for their own knowledge graphs. Same for Amazon and all of these big companies. For example, Google, if I went to Google now and searched for, let's say for, I don't know, Nikola Tesla, I will get a bunch of results of some websites, right, that somehow are connected to the term Nikola Tesla. But also on the right, you might have noticed you get some sort of box. Actually, let me do it. Why don't I do it? So if I go to Google, and say, okay, Nikola Tesla. So Google's, I'm not sure how visible it is, but actually it's going to see, as you can see on the left, you see the standard search results, and there's like a bunch of them, and Google somehow sorts them on what it sort of thinks is relevant. But actually on the right, you see this thing here, which is that not string, but thing, which is actually Google understanding that this guy, this was a person, and therefore that it has, this person was born at some point in time and died and had some education and parents and so on, and had some descriptions. So basically, actually, this is an entity coming from the Google Knowledge Graph directly. Yeah, today I'll show you how we can do that in Web3. But anyhow, you might have not known that, but you've been interacting with knowledge graphs quite a bit, and they've been interacting with you every time when Amazon suggests you something to buy, you know, based on your previous preferences. Okay, so we're here. So far, so good? Okay, awesome. Then illustration of a knowledge graph, very simple one. So think of just kind of a graph of data where you have a bunch of entities that are somehow related. And in this case, we have Mona Lisa. This is like the basic example from the actual standard from W3C. The standard is called RDF. And basically, we have Mona Lisa, which is in Louvre, James, who likes Mona Lisa, and Lily, who is a friend of James, and so on and so on, Da Vinci, who painted Mona Lisa. If you were to represent this somehow in, well, semantic terms, using RDF is like the standardized way. And RDF uses some notion of the data structure called triples. And it basically looks like this. You have like Da Vinci painted Mona Lisa. You have this video is about Mona Lisa, or Mona Lisa is in Louvre. So basically you have these triples which have this structure called subject, predicate, object structure. So you have some subject, some object, and there's some relation between them. And with this very simple primitive, you're able to actually model anything. So you can create a very complex graph while still maintaining semantics. And this is overly simplifying it, but just to give you a bit of a notion of what a knowledge graph is. So think of having a database that structures all of the data like this, and then you're able to actually say, okay, you can ask a question, like you ask Google, who painted the Mona Lisa? And that will turn into a query, which will actually say, okay, I'm looking for an entity that's going to be the subject, and then the predicate should be painted, and the object should be Mona Lisa, right? And these queries are actually not that hard to write. I'll show you some today. But the basic point here is that this is how it looks like. And what I want to illustrate is that it actually looks like quite different from what we've seen in blockchains, right? We're not used to working with things like that. So we're working more like with the notion of primitives like transactions, addresses, accounts, and things like that. So, so a decentralized knowledge graph actually combines these two things. And the term Web3 basically, like I said, focuses on decentralization. I'm sure you've seen this before, this notion of read, write, own Web3. So therefore, the Semantic Web3 basically combines both of these visions in one. We get the Web3 as we know it, the read, write, own Web3, as well as having the properties of semantics. So we're trying to bring that value from Web2 that all of these major companies are benefiting on constantly from basically our data, the data that is produced by our usage of the internet. And well, we basically want to bring this to the Web3. So, all right, how do we do that? We will see over the next bunch of slides and a little bit of a tutorial. Briefly before that, I just want to introduce one important notion here. Where does this value come from? And essentially, I'm sure you all heard of network effects. So really briefly to introduce this notion of value, we observe information as something that's inherently valuable. So by definition, we start from there. And then basically having the decentralized knowledge graph, which is basically this graph that in a decentralized public context can connect a lot of inherently valuable information, right? We actually get network effects to be driven. And that's really, really useful when we look at assets, because it applies to them in 3 different ways. It makes them discoverable, like in Google, it makes them verifiable, like in a verifiable ledger, and finally valuable. And the guy who actually coined this term, his name is Bob Metcalf. By the way, one of our advisors, he's working with us together on this. He coined the law, Metcalf's law, which basically says that the value of a certain network is proportional to the square of the number of the participants in that network. So let's say telephone network, when they started with this law, telephone network was the way to explain it. So if you had like 10 people in the world who had phones, only these 10 people could call each other. The value of that network would be 10 squared, proportional to 10 squared, so around 100. But if you have 1,000 people, then all of a sudden you move to 1 million, right? So it's an exponential growth, and it actually has been shown to be true for social networks like Facebook, for example. If you look at the revenue as a proxy for value, you can see that the revenue curve has been growing somewhat like this. And not only on Facebook, you can actually read quite a bit about the Metcalfe's law there. So the idea here is that we observe these networks as actually networks of entities in a knowledge graph, networks of assets in Web3. And by making these networks, the core principle is that the bigger the network, the more we aggregate things in this knowledge graph, the bigger the value it is for everybody, in the same way as it is for Google and other companies that are doing knowledge graphs. And yeah, it's a very interesting quote at the bottom, which I like to always point out, is Robert Noyce, co-founder of Intel, said that knowledge is power, but knowledge shared is power multiplied, which again is kind of a different formulation for Metcalfe's law. All right, just a little bit more info about OriginTrail. So what I'm speaking today is not, just something to be built. It's actually already being in use, and there's quite a few global companies using OriginTrail. Actually, in the US, over 40% of imports are being basically secured by audits that are being exchanged by the biggest retailers here. So Walmart, Costco, Home Depot, Walt Disney, pretty much you name them, whatever you pick one, there will be at some point querying the knowledge graph for security audits of around 10,000 factories globally. Now these audits, they basically are used to assess the security of a certain factory, let's say in China, for example. Also, other examples are, like I said, British Standards Institution. So they're issuing, basically, it's an assurance and the compliance use case. They're issuing training certificates on the knowledge graph as verifiable certificates. The Swiss railway company is actually using the decentralized knowledge graph quite a lot. They're tracking physical assets that they own across Europe, because trains obviously move across Europe, right? A bunch of other use cases in fashion, food traceability in Europe. I'm not going to go too deep into them, but there's quite a few companies, actually businesses, using the technology already. So what can you do with it? You can basically build with semantic high-quality verifiable data, publish verifiable claims from any system. That can be a Web2 system as well, doesn't matter. You can integrate data across Web3 seamlessly in that knowledge graph sense, as we've seen that. Basically build privacy-first metaverse-ready dApps. I'll touch upon privacy a bit later. I'll show that in the example. You can crowdsource actually high-quality data sets. You can find them, like search and crowdsource them through something we call knowledge standards, which is in the making. And finally, tokenize your dynamic data assets. So that's a very brief intro. Now we're going to go a little bit on how it works. So what's under the hood? Basically, this is kind of a simplified sequence diagram where you can see the four main actors in this system. Actually, there's one additional important actor that's basically the blockchain, but we consider the decentralized knowledge graph, like I said, a synergy of blockchain and this knowledge graph network. So that basically is encompassed in this public DKG section here. So essentially, we have some data provider for a specific asset, and that the data provider, whoever that might be, would publish some data into the knowledge graph. That's in Web 2, that happens every time, for example, you do search in Google. That's the publish you've done to Google. Google stores that search information, probably actually a lot of other information about you, where you search from, what time, who you are, because you're logged into Google most likely. And basically, this piece of information ends up in the knowledge graph, constantly growing it. On the other hand, there's some data consumer, somebody who's maybe doing the search query, or somebody who they're selling the data to, who actually has some interface and reads it. And in this DKG sense, decentralized knowledge graph sense, this data consumer can do two things. And if you see these red dotted dashed lines, the first block here are actually called indexing and querying protocols. So these are protocols where you can actually implement different kinds of search or resolution, finding something by a specific ID, for example, or by a keyword, and then obviously indexing that into the graph. And then below that, we see data exchange protocols. So that's basically when you found something. For example, think of Google. When you've done a search, you found the page you wanted, you click on that page, you initiate this one-to-one data exchange in a way. So you came to the website or the source where you want it to be. And again, these protocols can be many. The point here is that the DKG is supporting different types of protocols in these two, let's say, wide groups. So conceptually, the architecture looks like this. We have some Web3 applications on top, like search applications, for example, or analytics. Somebody came to ask me about analytics at the beginning. Could be one of the applications. And then we have a couple of layers: service layer, the data layer, the network layer, and then the consensus layer. Consensus layer being obviously comprised of several blockchains. And from the get-go, from the beginning, we've actually designed OriginTrail implementation, but also the whole protocol not to be blockchain dependent. So it started on Ethereum, but essentially it doesn't have to live on one blockchain because the state is maintained here on the data layer. And actually the whole index and the whole knowledge graph is off-chain. Think of it like, let's say, an IPFS on steroids that is an off-chain verifiable network, but has these properties of semantics built in. And then whenever you need that data on the blockchain, well, there's the ability to basically provide that data, let's say through an oracle, into a smart contract and have these verifiability proofs in the contract. So let's say I submit some triple, Mona Lisa is in Louvre. If that was part of a data set that was indexed in the decentralized knowledge graph, you would be able to actually have a contract function that would confirm that this was indeed published by whoever, the Louvre, let's say. On the other hand, also there are services that don't necessarily need to rely on having data end up in the contracts itself. So you could think of applications that are querying the blockchain and the graph at the same time, and somehow, doing something sensible with that data. One important principle here, the way we're building it is from the get-go, we actually focus on neutrality. So the idea is to provide basically choice as much as possible. And that means that in all of these layers, it's not like, one graph solution that you have to use or one particular networking stack like LibBit2P, for example. You can use something different potentially. Like I said, these protocols can be implemented in different ways. You can pick your own blockchain, the one that you like for whatever reason. Maybe it's cheaper, or maybe you're religiously following this particular chain. Awesome, you can pick. But one key thing that enables this is actually following standards. So you've seen the semantic standards that I mentioned. I'll mention some other blockchain standards also coming up. So basically we're trying, whatever we build, we try not to reinvent the wheel. We're not the most clever people in the world, but we know who are. So we go and get what they make. Okay, so what is this Semantic Web3 asset? This is actually the first time I'm showing this. So yeah, might not be fully clear. Please throw some questions in if you guys don't, if I'm not clear. Anyhow, this is kind of a formal definition that is being, finalized as we speak. And basically it says that these Semantic Web3 assets, they are unique digital assets representing a real world asset so that it has a unique identifier. And actually we call that unique asset identifier, and correspondingly has a unique asset locator akin to URIs and URLs. They refer to a semantic representation of the real world asset. Some people might have heard of similar term like a digital twin, for example. That's kind of close to it, but not necessarily the same. And then obviously has state verifiability proofs, as I mentioned, on the blockchain itself. On a blockchain, you have actual fingerprints or cryptographic proofs where you can determine that some query result from the knowledge graph is actually immutable, so that you haven't put this state off the chain and lost this immutability property by having the data actually reside not on chain. So the point here being is that we're able to take in a lot more data. We're not constrained by how much you can fit in a transaction on a blockchain. You can publish 10 megabytes of highly structured data on the DKG, and then put actually two tiny fingerprints, one being the graph Merkle proof, which basically allows you to prove that a certain statement in a graph is actually part of that particular graph, and you can do that on the chain, and as well as have just a common hash that you can compute without actually going to this complex Merkle computation. So anyhow, these proofs are there. It also contains ownership record. So think of it as a state that's public, but you have ownership of it. So you can update it, you can change it, or you can transfer the ownership to somebody else. So I can sell, for example, my NFT to you, and then with this NFT, I also sell you the ability to update this state, which is referring to the NFT, so this Semantic Web3 asset. And finally, it can also contain an associated token pool. These last two are optional. And so what does this really look like? So think of it as pretty much the graph we've seen for Mona Lisa in the beginning. And think of it like, let's say, being maybe we can take an example of let's say a blockchain game, something like Axie Infinity. So you're playing this game, your axes are collecting a bunch of whatever power-ups, results. All of this growing amount of data is associated and currently stored somewhere. But basically, this can be turned into a Semantic Web3 asset. So imagine having an NFT with associated semantic verifiable state that when you transact or transfer, sell your NFT, you also sell that state. So somebody's able to then continue involving it. Kind of like, let's say, your Twitter profile, but when you sell it, somebody else has the password to continue using it, right? So that is the idea with all of these properties. All right, very briefly about UAIs and UALs. So what are these things? Might not be the most interesting thing in the world, but it's kind of new. Basically, it's universal asset identifiers and locators. They're based on the standards around URIs and URLs, basically the same scheme where the protocol is basically OriginTrail DKG. Basic idea is that if you go to that UAL, like that link, it basically resolves to the latest asset state graph fragment in the DKG. And it conforms to this generic syntax. So you've seen, this is the generic syntax of let's say, a URL. So it would be like, the scheme would be HTTPS maybe, and then you have some website like google.com and a query and so on. Well, in the Web3 space, Semantic Web3 space, we would have something like this. So very similar, just instead of the scheme being HTTPS, we have DKG as a scheme. We again have a query fragment and so on. So that means that, for example, we could have something like this. This would be some address, some UAI, and let's say I want to take that asset at that address, and I want to get its name. So I just do hash name, or I want to get whatever other property. I can do that, or I can write a query actually in there. And the point here being is that under the hood, the system understands this and converts it into a query, so you don't have to write a query. And it returns the proper result, what you actually asked for, and then you're able to verify that what you got is actually hasn't been changed and has been issued by the actual authority. So the version 6 that I mentioned that is being built of OriginTrail is actually what is the first implementation of this new concept of UAIs and UALs. All right. So these things, as I said, are compatible with a bunch of standards. And who here has heard of DIDs? Has anybody used DIDs? There's 1, 2, okay, cool. So perhaps just a brief intro on DIDs. This is W3C, I believe, standard, not recommendation. I think right now it's become a standard, which basically defines this format. Not yet, right? Not yet.
There was a formal objection, and it's still working through it. And the groups that formally objected were the groups that don't want the DID, which is Mozilla, Microsoft, Google, and Apple. So they have a vote, they're voting associates, and of the 41, there are 4 objections.
Well, I wonder why. Yeah, but it's like, well, we gotta fight the good fight, right? So, but anyhow, basically a DID. You guys all have Ethereum addresses, I'm sure. So that 0x whatever 123, right? Well, a DID of that address could be, for example, DID : ETHR colon that address. And that says, okay, this identifier actually is attributed to an address on Ethereum. And there's this specific method called ETHR, which basically, well, tells you what you can do with it. There are other kinds of DIDs. Pretty much every blockchain has its own DID space. So the idea with UAIs and UALs that basically they are also DIDs. So we've designed them to basically conform to the standard. So if you know about DIDs, you've heard about DID subjects. DID subjects is basically what the DID represents. So the real world assets are that DID subject in this case. So the actual graph representation of a DID is the DID document. And the asset owner is the DID controller. So finally, the DKG is that verifiable data registry that's been defined within soon-to-be standard when we win against these downloaders. But yeah, I mean, even though it's not a full standard yet, it's very usable. It's and there's a lot of stuff built around it already. So, for example, you have yeah, go ahead.
I was going to say, anybody who wants to get involved with this, the W3C DID standard is an open community forum. So anyone can go to the W3C, search for the DID, and you can subscribe to all of this in real time. The debate and discussion is open and freely available to anyone who signs up. And there are people that are as passionate as this guy and all of you are.
Thank you.
So jump in, it's pretty interesting.
Yeah, for those of you on the stream, that was a call to join the DID W3C working group, basically. It's open. But yeah, basically, there's a bunch of clever people making this, and there's already a lot of software supporting it. So just so you know, somebody hasn't like officially put a check mark next to it saying, okay, this is a standard, that doesn't mean it's not useful or usable. A bunch of identity solutions actually rely on them in all of the blockchain space. So anyhow, this is just a little bit of a, you know, an additional context on these. So how can you actually interface with the DKG? Well, basically, you have something called, well, you guessed it maybe, Semantic Web3.js, right? We have Web3.js, and plus link data, we get this Semantic Web3.js. So this is basically a new kid on the block. It's so new that we basically released it 2 days ago. Not even sure, to be honest. Oh, thank you. we flew like 20 hours to here, so I'm no longer sure what day it is. But yeah, luckily I can stand here and speak, which is good, which was not so last night. Anyhow, yeah, he's smiling, he knows. All right, so basically, there's a couple of ways to interact with the DKG. So you can use the Semantic Web3.js, which I'll show hopefully very soon. And there's a couple of clients. So we're actually working on building clients as a team, the Trace Labs. We are the core developers of OriginTrail, but also the community is working on clients. There's actually just today I found out the community member made a Java client. And we have actually a call open up for clients. So if anybody is interested in making a client, there's a quite nice bounty you can earn. We're looking for Python clients, Rust. Actually, we have a bit of a Rust client already. We need a Go client. People actually ask for it. It's not that easy to build all of it on your own. So that's where we're trying to leverage, well, other clever people in the OriginTrail community. PHP client also. Yeah, we heard we needed that as well. So how can you query for assets? Well, if you're using the Semantic Web3.js, which I'll show you very soon, actually it's super easy to query the DKG. So when I say query, if let's say you're a developer or you're like a back-end oriented developer, whatever that means, you're thinking of a query maybe as a database query, right? Which is cool, you know, I mean, but you need to know how to write database queries. If you're more of like a front-end guy or somebody who's maybe learned how to use Web3.js in the front end, you might not necessarily know how to write like SQL queries or even GraphQL. So for you, the first way, actually, I'm missing something here. Yeah, so the first way is proxy objects. So think of this being your JavaScript code, and you have some variable NFT name. And what you just do is you say, okay, await UAL.name. And cannot really be more simple than that. All you need to know is, well, you need to know this URL, right? You need to know this address. And anybody a JavaScript guy here? Do you notice something weird in this first line? Yeah. Yeah, it's weird that it's in a wait, right? The reason is, and that's why it says these proxy objects. There's actually under the hood, there's what is called a proxy object, which is implemented, and you see it in the code as kind of the object, but underneath there is actually functions implemented, so you can use await. And what it does, it actually calls remotely the DKG object, the asset, its latest state. It finds it and gets queries for the name and returns it to you. So in the front-end code, you don't really need to do anything except providing, well, you need to load Semantic Web3.js. You need to provide like an RPC URL, pretty much like Infura gives you for Ethereum, well, same thing. And then you use these queries. So you can load, let's say, any Semantic Web3 asset data just by doing that. Or if you need something a little more complex, if you want to run a query, let's say, I don't know, you want to calculate the average whatever score of some NFT game, whatever players, I don't know, the average score shooting in a football team of Barcelona and whatever, you could do that because you can run a query. And that query looks pretty much like a SQL query, select AVG average of, I don't know, shooting from BKG where team equals Barcelona. If you've done something like that. So I obviously didn't show it here, but I'll basically show it there. So how you do it? Well, you basically say dkg.query, query string, and actually missing an await here. So that's one small error. But anyhow, that's kind of the idea. The point here was not to create something that's super hard to use, that you need to know that whole stack that Tim Berners-Lee said, RDF, XML, all of these, sometimes even archaic technologies. The idea is, JavaScript, and you're good to go. All right. So now I mentioned this Sparkle thing, just to give you an example of what it is. It's actually a whole protocol, but it's not so important for us. But it's basically the standardized way to create knowledge graphs. So, for example, a query in Sparkle might look like this: select name, mbox, mailbox, right? Where, and then it has some conditions. These are actually called pattern fragments. So basically, triple patterns. Sorry, and these triple patterns say that I'm looking for a person that has the name equals this variable name, and this mailbox equals the variable mbox. So I'm looking for a name and mbox where these are actually marked with these properties: FOF, name, FOF, mbox. This FOF is actually short for friend of a friend. It's a common ontology in the semantic web world. So basically, kind of a social networky type of an ontology. And if you haven't heard of the term ontology, that's basically just the definition of, let's say, the format of knowledge. You define a term like friend, or you define a term person, or things like that. And well, Google actually made a lot of the internet go and follow their own ontologies or schema. So who here has used schema.org ever? Okay, some people. So basically it's a website that specifies, let's say if you have an online shop, you're selling something, and you want Google to find your results a little better. Let's say you're selling books, I don't know. There's actually a standardized type or ontology for book, and if you call, let's say, the properties the right name, Google is going to be able to understand it because it's going to be able to query it. So therefore, you're going to be higher up in the search results because Google incentivizes you doing your part and structuring the data and the way that they like, right? So very similarly here, the more you structure your data, the more complex or interesting queries or questions you can ask the knowledge graph. And here, this was a very simple example of a Sparkle query from actually the Sparkle's official website. But the point here is that these queries are not that different from your usual MySQL or whatever type of relational query you've been using. So you don't need to learn a lot to figure out how to use a knowledge graph. So how would this actually work? So if you're building a Web3 app, you would basically have Web3.js, would have Semantic Web3.js in your app, loading in, let's say, index.html. I'm actually going to show I believe, kind of ugly app very soon that does this. And what it does is actually interfaces with the DKG index. So that's pretty much like the Google search index. And you can do search. You can do dot search, like for a keyword. Or you can do dot query. Or you can do that await thing, and it would actually find where this particular piece of information on that asset is hosted in the triple store layer, on the data layer of the knowledge graph. So that's where the actual state graph resides. Now, when I say state graph, what do we really mean? Well, we have an asset like an NFT, and its state can evolve over time. When I say its state, I mean the semantic representation. And the owner is able to update that state, owner or multiple owners. And that means, think of it as more like a Git type of a thing. You're in Git, you're writing some code, you create a commit, right? And that's like one state. And then you're writing some more code, and then you create another commit, and that's another state. And you're basically able to transition from one commit to the other because, well, you know exactly what happened in between, right? So think of your NFT being a Git-like thing, where actually you can create a bunch of commits for its state, which is semantic, which you can query. And you can get, like, for example, by default, you get the latest state, but you can get the states from like 2 weeks ago or whatever. It's, you know, something you can do. And for each state, there's basically a record on the blockchain, which is really this hash that I mentioned, so Merkle proof, and another just basic hash, which you can actually use to verify what is the latest state, for example, because always you have a latest state variable, so you're sure that you're reading the right thing. And you're also sure who's the owner, so the contract won't let somebody else update state. So that means somebody can publish something, but they're not able to update the contract state on or whatever the contract is on the blockchain. And therefore, when you query for some asset, there's no way that somebody can like spam your asset. It should basically always verifiable states. And that, like I said, it can be any chain. All right, so actually, this is no longer pseudocode. This is part of an old slide. So instead of having the usual CRUD, create, read, update, delete type of thing, we actually have CRUD. That's a new term. Let's see if it sticks. So create, read, update, and transfer. In Serbian, where I come from, it sounds a little funny, so we might change it. All right, so what you can do, you can create an asset like this. You say await DKG assets, create, you send the content, this is semantic content, and you can have some options. And one of these options is actually visibility. So you're able to create part of the asset to even be private. So it's not hosted in a decentralized way. You can host it on a server of your own somewhere. And then that actually opens up some interesting properties because it's still verifiable. You can compute that the hashes are the way they should be, that they match. But you're able to actually sell the data because it's not public, right? If everybody can query it, then you cannot sell it. But if you have a bunch of interesting data, maybe you're like some, let's say, research institute that creates a bunch of interesting stuff, or you have a bunch of sensors around the world where this data might be interesting, you're able to actually create basically a data marketplace. And I'll mention a little bit about that later. So this would be how you create it. You get it, which is the read. By UAL, you can update the state. Well, basically, you need to provide a UAL just so we can say, okay, this is the asset I'm updating, or UAI. Basically, these are interchangeable. Transfer, pretty much the same as in, let's say, ERC20. So actually, this is completely implemented on blockchain. This has nothing to do with the knowledge graph, the graph itself. So the ownership is actually just a record on chain. And it's interesting here because we try to make it so that you can inherit ownership. So let's say you're creating a Semantic Web3 asset out of your NFT because the ownership record is already in, let's say, the ERC721 contract for your NFT. There's no need to re-implement ownership here. So when you sell your NFT, you basically immediately solve the state. So it kind of becomes one asset together, and living in an extended network. Okay, I think 2 more slides before I show how it actually works. I hope I haven't bored everyone to death with technical details. But anyhow, I say states, but what I actually mean is something called assertions. So every time you update a state, you make an assertion. You say, all right, my NFT, whatever, has this state now. I'm allowed to do that because, well, it's my NFT. I can say whatever. ETHDenver is where my NFT lives, and that's the state, whatever. But basically, I made an assertion. What that means is that it has a certain issuer, me, it has a certain structure, and it has a certain set of proofs, out of which actually we create these states. So they're actually based on another recommendation by W3C called Verifiable Credentials. Should I even ask? Yes. He knows. Another person that knows.
Another working group you can join.
Yeah, it's actually pretty good. Verifiable credentials go sort of hand in hand with DITs. So think of having like a JSON file which you signed and has a certain structure. So you can basically say, all right, this whatever diploma is now a verifiable credential, and it's according to the W3C standards. So you can do kind of very cool things with it. It's actually JSON LD based, so that means it converts to RDF. Yes, go ahead.
Are you going to talk about the trust triangle too?
I was thinking to, but every time I do that, it kind of opens up a 15-minute story, you know. But we can maybe, yeah. It's basically, yeah. Why not? Let's not have a slide for it, but essentially, this verifiable credential or this verifiability concept has, let's say, four entities involved. You have some issuer of this credential. So in this case, that would be me, or maybe like a government issues you a passport. So that's the issuer, right? You have some holder, which is, let's say, if we take the passport analogy, I can be the holder of my own passport, but I should also be able to keep it on my own. So I don't post like a scan of my passport online for obvious reasons, right? And then we have some verifier who might be, I don't know, US Customs or Border Protection. They see my passport, they saw it 2 days ago when I came in, and they verified like, all right, this seems like a legit passport and with the proper visa, right? But in this verifiable credential sense, we actually have this fourth component, which is called the verifiable data registry. So think of not having your physical passport anymore. Think of having a blockchain record that has been, so your passport, but like only a tiny proof has been stored, let's say, on Ethereum. And the government issues you a file for your safekeeping somewhere, let's say your wallet, for clarity purposes. So you keep this in your wallet and you show it only to somebody when they need to see it. And perhaps you show it at, I don't know, when you're going to a club and you want to show that you're over 21, your app, whatever that is, maybe a phone, is able to show only that particular piece of information, saying, okay, I'm over 21, but you don't need to know where I live, right? As opposed to, for example, showing them, when I show them my passport, they know where I live, which I don't really like. Why should they know that? So the point there being is that when you have these verifiable credentials, you have kind of a very powered up system of credentials where somebody can issue something, somebody can verify it, the holder can keep it for himself, but they use the blockchain as like the truth machine that shows that the holder hasn't modified their passport, so falsified it in some way and so on. And it's a bulletproof system. So these assertions are basically verifiable credentials. They're natively RDF based, and they contain this ID. So that's basically state ID or state commit hash, some metadata saying who's the issuer, what are the keywords associated with this particular assertion, and then the data, which is the asset state. So that's, think of it as just some random JSON thing. You can put in here whatever you want. So that's your payload. And then we have two proofs, like I said, on chain. I said it a couple of times. So this ensures verifiability. Basically, this one is calculated as a hash. So the ID, kind of like on IPFS, you do a content hash, right? And that's, you resolve the content by that ID, CID, content ID. Well, that's pretty much the same idea here. We just hash metadata and data, so the whole thing is verifiable. And that also contains this additional graph Merkle proof. So that means if you have a very big graph and you want to say, okay, is something part of the graph? Well, you can construct the Merkle proof around it and show that, you don't necessarily maybe need to query 100 megabytes of data. You can maybe get like a tiny piece, which is measured in kilobytes, and you get a small proof. And because Merkle proofs are quite efficient, right? They have log of n efficiency. So we can actually take quite a big chunk of data, quite a big graph, serialize it, create this Merkle proof on top, and just prove that, all right, something is indeed there. Like, for example, my age is 34, and that's part of this verifiable credential that I'm showing to whoever at the club, maybe Tiesto tonight, right? All right. So this is one of the core primitives. We have an assertion, we have the UAI and UAL, and then we have an asset which is basically comprised of, let's say, a Git-like structure of these assertions. Now, when I say Git-like, we don't really have branching yet. We might, we'll see. But basically, that is kind of the idea. You have sequence of states. Finally, RDF is the native format for assertions. So basically, that allows us to do those Sparkle queries that I mentioned, but also GraphQL things, not just semantic web standard things. Common serialization is JSON-LD, which is another W3C thing. Actually allows you very high flexibility in data representation. And because that's standard, you get some cool things. All of a sudden, you can query the Google Knowledge Graph through the decentralized knowledge graph. Like you can literally call it the knowledge graph of knowledge graphs. And that doesn't happen in Web 2. Why? Well, because they don't want to do it, right? They don't want to share knowledge graphs. But for us in Web 3, hell yeah, let's do it. Let's query all of their knowledge graphs together through our own decentralized knowledge graph. And well, in that case, we increase that n, and the n square goes even more exponential. So there you go. They take data from us, we take data from them. All right, so what we're doing here is really recreating basically Web 2 functionalities like search using asset connectivity. And just to paint a couple of ideas here, which are not yet built, but are very exciting, at least in my opinion. For example, Google search. You might have heard of this PageRank algorithm. Well, basically, Google became big because of it. Larry Page, therefore PageRank, has created an algorithm that says, okay, I'm going to rank sites by the property of how many other sites link to it. So if you have a very relevant website, that means a lot of other websites will link to it. I don't know, CNN.com, there's a lot of links to it maybe, so therefore it's going to show up when I look for news. Before my website, which is not, well, doesn't have that many links, right? Well, basically now we are able to do this in a Web3 way with verifiable links. Because all of this data is verifiable, we're able to take URLs and say, all right, for this particular search term, we have this particular asset being the most relevant and using the same basically open source algorithm. Another thing we can do is to token created registries. Used to be a thing in Ethereum space, no longer mentioned that much, TCRs. But essentially what it lets you do is let you create a list of things, and then you're able to stake tokens on a certain thing, let's say, and you're able to sort by the amount of stake. So the premise is that the more stake on a certain thing, the more valuable it is, because people literally put their money where their mouth is, right? Well, in this case, we can use that for search. So we use it just like Google uses AdSense. So you go and pay to be the first in, I don't know, Denver for whatever techno clubs. Let's say that's what you have, a techno club. You want to make a commercial for it in Google. You go pay Google. Well, here we can do it in the Web3 way. You can go and stake some tokens, and you don't pay anyone. You just lock some tokens, put your money where your mouth is, and voila, we use AdSense, exact same principle. Decentralized semantic search. So what I'm going to show you is actually keyword search, but decentralized semantic search is that thing we saw with Google where it understands that actually, for example, Nikola Tesla is a person. So we can build that pretty much on this system. And then we have SEO, so quite a big industry, as a function of verifiable asset content. So you can, let's say, incentivize people to create more richer semantic Web3 assets, and therefore, because they're richer and they can be more useful, you increase that N, right? You have a lot more data, then you can be, let's say, better positioned in an SEO sense. Finally, this data portability is one of the coolest things. You're able to actually have data assets, not just NFTs, but really any data asset, and you can move it from place to place because it's standardized, and therefore you don't have to stick with it on, let's say, on a particular blockchain. Finally, promise last idea, token-based access control. Remember when I mentioned that you might keep some part of your asset state private? Well, you can decide to actually sell access to it. Somebody buys what we call a knowledge token, and you let them access it from time to time, or maybe for a certain period of time, or whatever type of setting you create. So the idea there is that you provide something that was previously not on the market. In that sense, you actually let it be on the market. All right. So finally, I'm going to do a little bit of coding just to show you how you can do this. But actually, before that, before we go into coding, I'm going to show you a short demo, which is a thing we call the supercharger for NFTs. So, oh, okay. So do you guys see that? Yeah. So this is actually an interface that we were building, which, as we call it, supercharges NFTs. But actually, what it does, it creates these Semantic Web assets, Semantic Web3 assets. So I'm going to go ahead and I'm going to do that for a random NFT. And I'm actually going to pick, let's say, did I click? Yep. All right. So first of all, I'm going to show you how search works. So I'm going to search for, let's say, Axie Infinity. So I can go ahead and click search. And, well, kind of the regular search thing happens, right? Regular in the sense that it very much looks like Google search, but actually it's all decentralized. This is a query on the decentralized knowledge graph. And it returns me all of the axes sorted in some order. And let's say, imagine that I own this Axie 1004, let's say. I can supercharge it or create this Semantic Web3 asset around it. One of the cool things I can do is I can connect it with other NFTs. So let me search for some more axes, and I'm going to connect with a bunch, random group of axes. So maybe this one and this one and this one. And so, yeah, I'm going to basically create a bunch of connections here, and I'm going to go and now add a couple more things. I'm actually adding metadata. In this step, I'm going to index this NFT. I'm going to add keywords, search keywords. So let's say ETHDenver, then maybe, I don't know, Axie, then I don't know who I know here. I know Amos, I know Jason. Let's say those are search terms. And we can go to the next and final step. I can add basically metadata. It says here rich metadata. This is key value pairs, but you can really create any type of a graph. So let's say this actually has superpower of, I don't know, flying. And I can add another value, which can be whatever, color green, and can be occupation, I don't know, magician or something. And if I go to supercharge, did I click this properly? All right, my MetaMask is not opening. Try that again. Okay. Ah, here it is. Okay, one more time. Let's see. Here it is. So basically what I'm doing, I'm doing this issuance of an assertion that as I spoke previously. So I'm signing literally the whole document here, which is not like the ideal thing to do. We usually actually sign only the hash. But this, like I said, this is a demo. So it's not a fully productive app. And now what is happening in the background, actually, this is being published to the OriginTrail Decentralized Knowledge Graph. So it's creating a new Semantic Web3 asset, and now it's going to load. And what it's going to load is just kind of a very simple interface that showcases kind of a profile of this NFT. Yes, question.
Were those the triples themselves? Like, is there a corpus of relationships that you have to work with, or can you make anything you want to be the verb or the adjective?
Very good question. So technically, you can do whatever you want, but that limits, in a way, the abilities to query them. So the more, let's say, the more structure or ontology you follow, the better it is in that sense. So let's say you could, and that's, by the way, one of the things we're working on. We're defining an NFT ontology on how you can create such an asset so that we have a standardized, well, basically metadata structure. But that doesn't stop you from putting anything in there. And I'll show you right after this, in code, you can see it. But basically, what we created here is a bunch of triples. And if you look at the data on the side, well, it kind of shows you the common, data about an NFT. So ERC725, what is the contract? Actually, you see a DID here. Not formatted properly because it shouldn't be Ethereum here. It should be ETHR. So yeah, demo. And actually, it shows you this metadata. So basically the stuff that I added just now, occupation, stuff like that. It shows connected assets below. So I connected with these three. But what's kind of like the point of this interface is also to showcase these queries. So I can, for example, query all NFTs connected with NFTs. So when I click run this query, this is how the query looks like. Probably not the best font to show you, but basically it looks for NFTs that are in this relationship of is connected with another NFT, and it gives us actually 3 DIDs of NFTs. This basically these ones here, and as you can see here, this is token ID 1, 10, and 100. You can kind of see it here, 1, 10, 100. So that's directly the result of the query. Then you can do some other query, for example, history of the NFT. It looks a little bigger. So if you run that query, it gives you a lot more triples. Now this is not the best human readable form, right? That's why we don't like. I mean, we can see some things here, for example, Ronin, blockchain, we see Amos, JSON, the keywords that I added for search. But basically, it's all a representation of the graph coming back to me in this interface as triples. And normally, as a developer, you would convert this to JSON LD. So you're not going to work with this. This is really just enabling this graph representation. We can also plot this graph. So if you look at the graph here, it's kind of like a little twiddly around. You actually see some interesting things. For example, I haven't talked about this at all, but this is kind of one of the core concepts in knowledge graphs. You have this schema.org/token, schema.org/topics. The point here is, and that's partly related to your question, is that you use something of a property that already exists. And if you go to schema.org, you'll be able to find, let's say, person. And then this person is actually an object of its own. So you can use schema.org/person, and then every system that understands that ontology is able to understand this thing. So the idea is to leverage that. Now, obviously, schema.org/token doesn't exist yet. But it's up to us to create a bunch of these new Web3 ontologies, really. And then finally, if you look at this verifiability function, this is again a demo, but I can show you 2 assertions here, 2 different types of assertions that are been published to the same NFT. And it's not so visible here, but like you can see at least some of it changes. These assertions actually have corresponding hashes on the Polygon blockchain, and the interface has actually read these hashes and has verified that the issuer. Well, in this case, the data model is correct, that the assertion hasn't been changed, so that what I got in the interface, I actually don't need to trust the DKG at all. I get some query result, I go to the blockchain independently, I compute that in my own interface and say true or not. If not, all right, I don't care. I'm going to do another query, or I'm just going to drop the data. But I don't inherently trust anything. And that's that concept of verifiable credentials that I mentioned. So that in this case, you're the verifier. You're reading some data, and you verify the issuer, you verify the structure, and then you verify the integrity. So this is a very, well, let's say, simple demo of what a semantic Web3 asset is. And now, so we have some time. I can show you literally in code, like not going to be the best coding session ever, but it's going to show you how we can actually create a couple of assets. So I created some very simple Yeoman, of course, there's some errors on the side, very simple Yeoman web app, use the Yeoman generator. And basically the idea here is, like I said, it's not the most beautiful one, but the idea is to create an asset, to update some states, to query them, to do a search, and so on. And I actually haven't implemented all of this. I just implemented the first one. So the idea is to show you how you would implement it in your front end. So basically I should have a WebStorm open, yes. So one sec. Just zoom in a little bit. Can you guys see that? Is that okay? Awesome. So all right, this is like your simplest possible web app, basically scaffolded by Yeoman. So what it has some index HTML, which is kind of simple. And what's really the more important thing here is, and I'm going to zoom in a little bit, is, let me just see, Web3. So as you can see, I've included Web3 JS from a CDN, and I also included Semantic Web3. I actually did npm install Semantic Web3, so it's included here as a script. There's a bunch of other things included, but they're not really, they're not needed, but just for the sake of this app, they came with it in a way. And then I'm going to write a bunch of code here in this main .js file. There's some HTML here, like you've seen in the browser, so just so we don't lose time on that. And basically, I've created this first function, which is creating an asset. And as you can see, it's an async function because it needs to obviously run run this. But if you look at it, what it does is does a very dirty jQuery loading of data from a text area, where I will just write a very simple JSON in a second. And what it does, it actually does this. It says, await dkg.assets.create. So dkg here is like your Web3, web3.eth.accounts, same logic. And what you send it here is basically some content. So that's the JSON that we will get from that placeholder text area. Then some keywords, like for example, ETHDenver 1, 2, 3, whatever. I can add something like, I don't know, Amos, he's over there. And then there's this visibility. That's the part I mentioned about something being potentially private. And so now when I actually click that button over there, because this is classic JavaScript on click, it's actually going to run this. And once it actually gets created, it's going to return a UAL. It's going to provision a UAL for this asset, and it's going to actually put it in the front end. So let's go and do it. Oh, that's the wrong browser. Brave. So, like I said, let's do some very simple JSON here. Let's say foo bar and maybe something else, maybe like city, Denver. So this is a very simple one. This is barely any semantics in it, but just for the purposes of, let's say, showing a hello world, let me go ahead and do it. So I'll click create, and we can actually even look at the console. So prior to actually running this, I made sure that I'm connected to a DKG node. I'll show you that in a second. When I click create, basically what it does, it asks me to sign with MetaMask, right? I'm issuing this assertion for the DKG for this asset, this foo bar city Denver asset, whatever that is. And when I sign it, it actually sends, it publishes this into the DKG. And because this takes a little bit, it's a decentralized network, it's just been published. It says here that the publish result has been completed. And then here below, the actual URL has been populated. So you can see this URL, which actually UAI here in this case, which is basically a hash of this asset and its metadata. So what I can do now is I can actually, let's go into the code. And I can, for example, get asset state. So let's say we can, or maybe even I can do it even here. So one thing I forgot to show is how you connect to the graph. So to initialize the connection, you do something like this. Here at this moment, if you want to try it on your own, you can try and connect to this particular node. So this node is open. This is an OriginTrail version 6 node. And it has a dedicated port, 8900. And basically, once this connection has happened, you initialize this Semantic Web3 object, which here is called basically the DKG object. And the first thing I actually initiated was this node info. So this is basically just like checking if the node works. And if you see in the log here, there's, well, it's kind of tiny. I'm not sure if you can see it, but basically it says, okay, the node is running version 6 beta 123 and has certain properties set up. So basically we successfully connected to the node. And so now if I want to get, for example, this asset, let me first get some water. I can actually, let's do it up here. So I can say, let's hack it a little bit. So let's say, I'm just going to paste what I got. And then we can say, all right, result equal await DKG assets get. And here we actually just add the UAL. All right. And I've been speaking for an hour and no water. That's not working. Okay. So, okay. And then let's say we just like console log it. Should get it now. I think I have this function tied somewhere to click. Yeah, so there's a get state one. So if I click get state here, actually sending a resolve request, I actually got the state back. And what you see here is, again, not the biggest font in the world, but we actually have a proxy object, as I mentioned. So this proxy is why I can do await dot something. And this case, because I actually put it in a so I made a mistake here. I should actually put it in a global object just for purposes of showing it. So let's say, let's do this. Oop. So it's a little, it's dirty as hell, but it should work. Oop. Wrong one. So again, get state, sends a resolve request. Oh, result is not defined. All right, because I console logged the wrong thing. Okay, one more time. Get state. We're resolving the state of that asset. And now I should be able to do this. So let's say I can actually do something like this. I can say result asset dot data. And then let's say, remember we had a foo property. I can say foo and let's say value of, and that should, oops, all right. I didn't type something right. Sorry, I missed something there. What did I miss? Like I said, it's new, so I haven't, let me see, I had a get here somewhere. I'm gonna show you a better result in a second. So this is for proof. One sec. Yeah, should compute. So dot data value of, let's see, like this should work. Oh, okay, yeah, there it is. So what I actually get back is a graph of the asset data. So I have the account who published it, I have the city, Denver, the foo bar properties, and the proofs. Not sure how visible that is because I'm kind of a small screen, but I can actually log it here in the. Let's do it like this. Let's do a better example even. So I have a more complicated actually token content, and I can copy it from here. So let's say we create another asset here, and this time we actually don't load that thing, but we actually take a little bit more complex JSON, and I'll show you. This is a draft actually of a spec of ERC 721 type of an asset. So if you can see here, this is a little bit more complicated JSON LD, or actually linked data object, which has a type of ERC 721, has some asset data where I can add any type of properties, perhaps a link to OpenSea, has a native blockchain, has some on-chain data for the purposes here, where I just put some random stuff, but basically has pretty much anything you can catch from the on-chain data, ERC 721, that standardized metadata, right? We had that image name description type of thing. And then we can publish this. So we can actually create an asset out of this. So I'm going to go ahead and do that. Oh, again, wrong browser. So if I click create, again, I'm signing its fingerprint. The publish request went ahead. It's pending a little bit. And then when it's completed, I get a URL. So I actually am able to get this particular asset back. So if I do another get, let's say here, where was it? I do the same thing, and it should log this result asset again. So let's say, where is it? Get state, sending a resolve request. It gets basically the same asset. Not super interesting, but what I can do is now I can say result asset dot data await actually result asset dot data, and then I can pick some property from here. For example, I only might maybe need something like let's say I want to know what's the native blockchain, so I can do something along the lines of this without actually having to query anything like that. So I can say something like this, and it returns Polygon as the native blockchain, right? So basically kind of a getter and setter. Go ahead, yes?
Yeah. Hi. I think I missed the first 40 minutes of this, so sorry if you already touched this. But right now I'm speaking to you on how is this really different from more specific, let's say, address, let's say, all the other blockchain codes. What advantage do you decentralized knowledge?
It's a very good question. So I'll just repeat it for people who couldn't hear it. So what is the difference between querying this type of querying and querying, let's say, a smart contract, if I understood you correctly? So querying some value from a smart contract, and what's the benefit? So actually, this is in this way, it's pretty much the same, but that's when we're actually fetching the particular state of some property. What it actually gives advantage for in knowledge graph is actually having the opportunity to run any type of query. And I don't know if you caught that Sparkle query talk, but I'm actually going to show it now. So basically, you're able to query. You have basically database properties that blockchain doesn't give you. That's kind of the core point. So in a blockchain, you can do getters and setters pretty much, but you cannot run a select something from somewhere where, I don't know, certain value is above 6 or whatever. You catch my drift? Does that make sense?
So are you building a very organized database of the history of the blockchain?
Yes. So the decentralized knowledge graph is like the most organized data structure basically that you can have. And the idea there is though that all of us collaboratively build this. So we publish our semantic assets in there, or data, or any type of records. And having this type of network also allows us to put a lot of verifiable data off-chain, so it doesn't bloat the chain state. So yeah, maybe you missed a little bit of the presentation. I hope that gives you a little bit of context. But yeah, feel free to ask more questions if you have it. Or not.
I mean, I have. I just want to think about this time. I missed the first 40 minutes.
It's okay. Maybe I finish a little bit of this, and then we can chat over a beer later. Awesome. Yeah, I'm up for it, definitely. So be very interested in any questions you guys might have, because like I said, we're showing this for the first time, so it's understandable for me because I work with this every day, but I'm like really curious how understandable it is to others. If it's not, it's good to know how we can improve. Another question. Very good question. So in this example that I'm showing now, we actually turned this off. But yes, essentially, the implementation of the smart contracts is designed so that it can recognize for typical assets like NFTs 721 1155, that it can recognize who the owner is and not let you create a state for it. Or any other, at this moment, any contract that implements basically Open Zeppelin ownable, let's say, contracts. So you can check, you can even create a Semantic Web asset for another smart contract, and we can check that it's owned by someone. But that's a very good point, and that's going back into the slides, like somewhere back here. Let's see. Yeah. So again, this Semantic Web3 asset has identifier. You see those URLs, semantic representation, which is what you can query, state verifiability proofs, and this ownership record. And ideally, the ownership record exists already somewhere. So if you're extending a metaverse-ready asset like an NFT, it already has ownership. But if you're taking a physical asset, like for example we do with the Swiss Railway Company, this physical asset, well, is not represented anywhere in the blockchain. So you basically provision it, you create it, and then we have a record. We create a record on chain that says, okay, this wallet owns this thing. That's basically the idea. All right, so a couple of more things we can show. For example, now I have a bunch of things here that are I just kind of commented out, but let's say we can do a query. So here's a query. Let's comment it out. So this query is, it will retrieve all connected URLs for a given URL. So I created some URL, I had some dummy URLs that it's connected to. And I can actually take that ID up there. Let's see, where is it? Here it is. So again, I'm hacking here like crazy, but basically what I'm going to do now is I'm going to take this URL and I create an options object that goes into the query, a call, which I lost somewhere. Let's say dot query. Here it is. I'm just going to copy it up there. Actually, might even leave it there. Yeah, even better. Let's leave it here. So let's say we can get all states for an asset. Oh, wrong asset. This one. And this would be the Sparkle query. So it says, give me all assertions, or their IDs, actually, where there's actually a relationship to another assertion that says, okay, it has URLs, it connects to URLs. And where this particular object on the right, this assertion ID, is actually this URL. So if I run this query and I run it like this, I say await dkg.query, and I send basically this query object is basically the minimal option, I will get the query result. So let's try it. This should actually execute immediately. All right, I made some problem here. Yeah, so 1 sec. URL, okay, should run. All right, here I get my query result, which is actually a triple result converted into JSON. So for easier looking into it, I'll just paste it here in WebStorm so we can see it very briefly. So this is what I got. I got that my query was completed. I got a certain triple. There's one triple because there's only one relationship to a different object. And so this is like one of the simplest queries you can do. Let's do the other one that I have commented out. So there's this little more complicated query. It says retrieve all connected URLs. So I have a bit of a different set of options. I'll just copy it here. And I can run that query. This query looks a little bit different, so we don't have to go really deep into it, but we can just run it. And if I run it here in the browser again, it takes a second. Here it is. It returns the query result pretty fast, actually. And let's see the results here, just for convenience. So basically, it gives me actually two triples. Two triples, as you can see, this is an array of triples which have particular URLs as subjects, and actually, as objects and a relationship of link to. And then as you parse this query result, you're basically able to do all kinds of database-related activity like this. Now, I'm showing some very simple queries, but that's essentially it. You can say, where is Mona Lisa in which particular museum, or you can ask, who have been the last 3 owners of an NFT, or you can ask what was the biggest purchase of whatever thing. So that's very simple example of querying, basically through Sparkle. Now I'm going to comment that out. I'm going to show you search. So if I remember correctly, we used Amos as tag, right? You probably remember it because Amos everybody. So I'm gonna just do a very simple search. Again, this is all, if somebody came a little later, this is all just simple front end. So I have it somewhere. Yeah, so here it is. So basically, I'm just gonna comment this out. The way I do search is I create another options object where I say, okay, I'm querying for, let's say ETHDenver, or let's say Amos. I think it was like this. And I want to get as a result type, and this is interesting, I can get 2 different types of results. Actually, this should be entities. Pardon me. So what I'm going to search for now are actually entities. And actually, that search probably executed in the background already. It did, because I just I said execute on load. So what we got in this search was actually the result. It's pasted here, that the search has been completed, and that we have. Oh, sorry, no, that's the same one previously. So that's not the search. Just one sec. Okay, maybe it didn't execute. Query results. No, I'm still not loading this. Did I save it? Let's see. Search, search, search. Okay, it's complaining about something. Missing. All right. There you go. That's the problem. Okay, still not getting it. Could be my jet lag, but yeah, basically that's the idea here. We run search with one command. Again, I'm missing something. All right. So that's the top one. Yeah, that's what you get when you dirty up your code like crazy. But yeah, trying to finish up here because there's the next session coming up. All right. Out of luck today. So I guess you guys should just trust me that it works. But basically, that's how you do it. So you just do a search and you get a bunch of results. So what you can get either entities, which are actually knowledge graph entities, or assets, or you can search for assertions. And that means just get states, individual states for each asset. Now, I'm totally clueless of why this is not working here. It should. There's no reason why it shouldn't. Let's just see one more time. If I didn't mess something, yeah, something's messed up. So probably just do this. So it should be very simple now. Duplicate code fragment. Okay, one last chance. Let's see if it runs. If not, I'm going to quit it here. I'm not in luck today. All right, you can actually download this and try it on your own. So you can go to npm, basically npm install Semantic Web3. We can show you. Oh, sorry, Semantic Web3. It's very new, so it hasn't been indexed by Google, I guess. So let's go to npm.js. So not Solana, but this one. You can go to npm. You can basically look at the documentation. There's a little bit of intro into the DKG, some architecture explanation, how you can include it into your code, basically run npm install. And then there's basically this example that I showed you here with all of these querying and search capabilities. There's also the ability to get proofs for a certain asset. So if you want to compute in your own interface, like I said, there's a query capabilities, there's transfer, so you can try it out. This is obviously still new, and to finish up this whole demo and presentation, what we are actually doing right now is we're running a bounty program for OriginTrail. So we're launching version 6 of the OriginTrail. What you have seen just now is something that's a work in progress, and we're looking for contributors. So we're looking for people who are interested in building the Semantic Web3 with us. If that was at all interesting to you, come join us on this link, origintrail.io/v6. There's some information about how you can contribute to the bounty. There's two ways, either by contributing code on GitHub or actually running the DKG version 6 node. So we have an ongoing competition with a scoreboard that's going to be live very soon. We're running a node which sends telemetry data to us as developers, provides us valuable data. And for that valuable data, the more useful data, the bigger the bounty you will get. So basically, anybody running an OriginTrail version 6 node will be eligible for bounty. All right, folks, then finally, one more thing. If you're passionate about building stuff like this, if it's at all remotely interesting to build knowledge graphs, get in touch with us. We have a very vibrant community. Some of the people are around here. Amos, Jason, very interesting folks, but also the team. Giga, my co-founder, is here as well. Yeah, we're very eager to meet everybody who's interested in stuff like this. We're also hiring, so feel free to come over and chat with us on that. All right, I think I spoke a lot. It's an hour and a half. Time to finish here. Let you guys ask any questions if you have any. Thank you for your attention. Sorry, what? Yeah, I'm shifting over there, yeah. All right. Any questions? You had some more? Sure. Oh, okay. One more new question. It's a very good question. So, an automation would essentially mean that something triggers the .create or .publish function into the graph, and in that sense, if let's say you have some sort of a marketplace or a game where NFTs are being constantly minted, this should be part of the code of that particular marketplace. So this particular interface should do that trigger. But it's a really good question. Yeah, that's. The point is not that people always come and do that manually. Absolutely. It should be part of the code. Cool. Had some more over there, or maybe later for beer? If you're up for it, I'm here. Shoot, man. Yeah, go ahead. We have 5-10 more minutes, I guess. The slot is until 3, but I should move a little earlier.
Yeah, I'm still confused on like what the value add. Because right now, this is more specific to, right? How would I want to do that?
So it's a good question. It makes total sense. So the idea here is to expand the use case from just querying the data that's on the chain, right? So think of it as, let's say, one way would be you have a constraint in the chain, which has obviously limits in size and cost of putting a lot of data on chain. Think of having much smaller limits in that sense, or barely any, and creating a semantic representation that is associated with your NFT. That's not the same data that lives on chain. So I only show that example because it's kind of easy to relate to, but necessarily you shouldn't be querying the DKG or adding data that's already on chain. You will be adding something different to it. For example, if you're having a game, let's say a game has some results, and these results get constantly produced, like you mentioned, it could be very cost prohibitive to put that on any chain, and hard to query later if you need it for the game. So in this way, you get this queryability property, you retain verifiability, and you obviously take a lot of this data off chain.
I'm pretty new, so I'm not. Is that a big problem?
Having a little hard time to hear. Can you be just a little louder? What's the problem?
I just don't know. Is that a big problem in the space of having, let's say, the metadata mismatching with what's supposed to be? And also, you were just saying, yeah, we don't store anything. We just store a bunch of things for
Yeah, so it's a good question. The point here being is this is an infrastructure that enables a lot of things. To be honest, I'm not sure if that problem is exactly something that's bothering the NFT community in the way that you mentioned. Might not be, but I was giving just examples in that direction. Think of it as a general purpose decentralized knowledge graph. You can store anything in there. Doesn't have to relate to NFTs. That can be any sort of structure, size, and it can relate and be used to any chain, while keeping all of this bloat off chain. So it's not focused on a specific problem. Think of it as like a very, let's say, specific graph-based database that you can use for anything, you know.
So is it like IPFS for like graph?
In a way, yeah, you might have missed that part. So I made a reference. The network is similar to IPFS. Actually, also implements libp2p. What it extends the IPFS with is actually the semantic capabilities that we've shown. So the ability to query, the ability to do searches, you know, things like that. But it is similar in a way. So I understand where the question comes from.
Yeah, sorry, that's the first one.
Totally fine, man. Hey, you'll probably be able, if you're interested to see it online, well, feel free to approach me any point in time. But thanks for the questions. They all make sense. All right. Yeah, well, go ahead if you have some more. I don't know. Oh, there's another question here. Let's let other people ask some questions. Yeah, go ahead. Oh. Yeah, so think of any type of search. Let's say searching for any type of asset. Could be metaverse, could be physical assets. Search is one great application. Anything where you need queryability to a little bit higher extent than just getting something that is part of, let's say, a record on chain. So anything where you might want to extend with a database with. For example, one of the cases that we've been very involved with was tracking of physical assets. Graph databases show really good there because you're able to represent the real world events very easily in a graph way. Actually, the way we learned we should use graphs was back in the day when we started working in this space, which is 10 years ago. We started without graphs. We used traditional SQL tables. And after a while, we realized that we couldn't fit pretty much data in this structure. We ended up emulating graphs. So we literally had a table of 3 columns, subject, predicate, object. So in that sense, for example, it's very useful for tracking things, like where they are, representing history of something. Yeah, those would be the first that come to mind. You had a question?
Yeah, I have 2.
Yeah, go ahead.
So is that extensible to the Web2 space, or is it pretty much limited to the Web2 space?
Really good question. The answer is yes, it's extendable. So there was a part where I mentioned that actually you can query Google Knowledge Graph through the DKG as well. So because we've based it on all of these standards that I've shown, JSON LD, verifiable credentials, RDF, all of these things, you're basically able to observe Google as a transparent part of this DKG. So some people call it knowledge graph of knowledge graphs for that reason. So yes, it doesn't exclude Web 2. It actually encompasses Web 2.
And is that presentation you had available?
Yeah, we'll share it online, definitely. But we can also, yeah, we can share contacts. I can send it to you as well. Awesome. All right, I guess one more question. Yeah, go ahead.
So you can make some of these entries private. How would you go about like accessing private?
Awesome question. Yes. So I didn't go into that on purpose because it's like kind of an additional rabbit hole. But the idea here is that you have a particular place where you host that private part of an assertion. And that would be, in this case, an OriginTrail node, but it can also be, for example, a solid pod. If you ever heard of the project Solid by Tim Berners-Lee. So basically, they're creating a tokenless network of pods. Like imagine you having your own server and you log into Facebook with your data that's hosted on your server. So when I chat with you on Facebook, that chat is stored on your and mine server and nowhere in between. Well, this is the same concept here, so that you have a server, and on this server or this node, you host some piece of data which is private. But it's still discoverable because it's part of the same knowledge graph. So if I run a query on the other side, I will see, hey, there's some more data there. You should ping that guy, So I can actually go into this data exchange protocol and sort of ask your node, hey, would you let me see this part of data? And if a certain condition is met, then your node might let me see it. For example, a condition could be that I purchased some token from you, or that I have a specific NFT or whatever. So that's the idea. This data doesn't then replicate on the network, so it's not decentralized. It's very much centralized, but the point is that it stays that it's your data, right? So it's not open data. It's something that you're able to monetize and then, or not even monetize, maybe just want to keep it private and then let some people access it. But yeah, that's the idea.
So if their server went down, and people paid access that.
Yeah, that's possible. That's possible. But then we get basically into the same system, same problem space as in Web 2. So if you're providing a certain service and you expect that service is somehow making you some money or something, you're supposed to keep that service up, right? So we as a protocol, we don't specify how to do this. This is something you can offer, right? And this is kind of a prerequisite for a knowledge or data marketplace to exist. So in this way, you can basically trade the data for tokens in that sense. If the data goes down, well, it's no longer in the market. That's as simple as that. Cool questions, all on point. Awesome. All right. I'm too jet lagged to be standing here anymore. So thank you, everyone, once again. If you have any questions at a time, just shoot them online. Thanks for the applause as well. And yeah, Trace on. See you.